All right, in this video we're going to introduce rational expressions, and we're going to determine the domain of these rational expressions, or in algebraic expressions in general, okay? In subsequent videos for this set of notes, we'll simplify rational expressions using factoring techniques we just learned, and we'll also multiply and divide rational expressions along the way, okay? So first off, let's define what a rational expression is. All right, it's a fractional expression where both the numerator and the denominator are polynomials, okay? So you can see some examples here of what we call polynomials in this case, or rational expressions. Constants like 1 are polynomials. You know, they're considered polynomials. So if the numerator is 1, that still means we've got a rational expression. All right. If the denominator is 1, like in this case, this would not be considered a rational expression. This is considered a polynomial expression with a denominator of 1, okay? But we want to be able to determine the domain of algebraic expressions, and later on in subsequent videos we'll be talking about, like I said, simplifying and then performing operations on rational expressions, okay? Now, with domain, if you have a denominator that has a variable in it, okay, that denominator cannot be 0, all right, because we can't divide by 0. Division by 0 is undefined, okay? So if you've got a variable expression in the denominator, you're going to set that equal to 0, and you're going to eliminate that from the domain, okay? The expression doesn't have a value there, so the domain doesn't exist there, okay? So we'll work on some problems where we've got a variable expression in the denominator. If you have a radical expression at any point in the fraction, okay? In this case, it's in the numerator. We cannot have negative values underneath the square root. That leads to what we call complex numbers or imaginary numbers, okay? So x, in this case, underneath the radical, has to be either greater than 0 or equal to 0. We call it non-negative. It cannot be negative, so that means it has to be positive or it has to be 0, okay? If you have a radical expression in the denominator, that eliminates 0 from the domain also. So in this case, x has to be positive, because if we take the square root of 0 here, 1 divided by 0 is still undefined, okay? So notice the difference when we have a radical expression in the numerator like this and in the denominator like this. What happens is 0 is eliminated from the domain if the radical expression is in the denominator, okay? If you've got just a basic polynomial expression, then x can be anything, okay? We don't have a denominator here. We don't have a radical expression here. So we say that the domain for an example like that, for a polynomial like that, is all real numbers, okay? So I'll let you guys read over this. We've got 3 practice problems here that we're going to do, okay? One where we've got a denominator here, variable expression in the denominator. Here we've got a radical expression and a variable expression in the denominator, okay? So in number 1, first off, that's a polynomial. There is no denominator. There is no radical expression. So the domain for number 1 is all real numbers, okay? In number 2, the numerator is irrelevant. I don't care about this x plus 2. That numerator can be any value, so I'm not concerned with that at all. The denominator, on the other hand, cannot be 0. So what I do is I set it equal to 0, all right? So I find out what value makes this denominator 0. Okay, so I'm going to solve that equation, and I get x equals 3, okay? So because x equals 3 makes this denominator 0, I'm going to eliminate it from my domain, okay? So we write the domain using that notation we learned earlier in the year. We've got all x values are in the domain such that x is not equal to 3. So any other value other than 3 that you plug into this expression, you're going to get a real number value. But if you plug in 3 to this expression, you get 5 divided by 0, which is undefined. So that's why it has to be eliminated from the domain, okay? So the domain again for this expression is all x such that x is not equal to 3, okay? In number 3, I've got a radical expression, so I'm going to need to deal with that. I've got a variable expression in the denominator, so I'm going to have to deal with that. So there's actually 2 things I need to do for number 3. First thing, let's deal with the radical expression. X has to be greater than or equal to 0. The radical is in the numerator, okay? So x has to be what we call non-negative, okay? If it's 0, that's okay. I'm going to get an answer for that. If it's +1, +2, and so on, I get a real number answer in the numerator, okay? So the numerator, the domain for that is x is greater than or equal to 0. Okay? Now let's deal with the denominator just like we did in number 2. Okay, so that's part of my domain. X has to be non-negative. In the denominator, I want to set that value equal to 0. So 2x minus 5 equals 0. I'm going to solve that equation, and I get x equals 5 halves. So if I plug in 5 halves to this expression, my denominator becomes 0, and the entire expression becomes undefined. So I need to eliminate that from my domain as well. I've already eliminated every negative number based on the numerator, but I also have to eliminate 5 halves. So the entire domain for this expression is all x, such that x is greater than or equal to 0, but excluding 5 halves. Okay? Every positive number works in this expression except for 5 halves. So we eliminate it from the domain doing that. Okay? So that's how you determine the domain if we've got variable expressions in the denominator or if we have radical expressions. So pause the video here and give 4 and 5 a try, okay? These are a little more complicated. Pause the video, give them a try, and then come back and check your work. Okay, in number 4, again, numerator, totally irrelevant. I don't care about it. There's no radical up there. It's just an x, so that can be anything, all right? The denominator is a quadratic trinomial that can be factored, okay? So I can factor that as x minus 3, x minus 2, okay? So I want to set each of these factors equal to 0 and find out what values make my denominator 0, okay? So let's set x minus 3 equal to 0. So 3 would make this denominator 0, so that needs to be excluded from the domain. And then also x minus 2 needs to be set equal to 0. So 2 also makes this entire denominator 0, so that would need to be excluded from the domain. So in this case, we've got 2 values excluded from the domain. Notice I put those in ascending order, x, such that x cannot equal 2 or 3, okay? Every other value for x will work in this expression. 2 and 3 would give us an undefined value, therefore they're excluded from the domain, okay? In 5, I've got a variable expression in my numerator, so I don't care about this at all. Any value will work here. In the denominator, I have a radical expression, okay? So the expression underneath the radical, negative 3x plus 8, can't be 0 because it's in the denominator, and it can't be negative because it's underneath the radical. So we're going to use this inequality. Negative 3x plus 8 has to be greater than or equal to 0. Okay. So when we solve that inequality, I'm going to subtract 8 from both sides. Don't forget, I know we're in an upper level class now, but don't forget when you divide inequalities by a negative value, the inequality symbol flips. So x has to be less than 8/3, okay? So that's going to be my domain, all x such that x is less than 8/3, okay? Any number, if I plug in 8/3 here, I get 0, so I get undefined. If I plug in a number bigger than 8/3, say, positive 10, for example, I get a negative value under the radical, which gives me an imaginary number, which is not a real number, okay? And the domain has to give us real number values for expressions or functions, okay? So that's how you find domain.